Hello dear students. Today I am going to tell you what is the difference between program, process, lightweight process and thread in a simple way. You are ready.
First let's know the definition of each of them. We start with definition of program. A program is executable software that runs on a computer. Examples of programs include web browsers, word processors, email clients, video games, and system utilities. These programs are often called applications, which can be used synonymously with software programs. On Windows, programs typically have an .exe file extension, while Macintosh programs have an app extension. A process is the execution of a program that performs the actions specified in that program. Process operations can be easily controlled with the help of PCB process control block. As the process executes, it changes state. But what are these states?
What is this state? Oh no, I want to know. Finally I know. Process states. The first state is new. Means the process is being created. And second state is ready. The process is waiting to be assigned to a processor. And third state is running. Instructions are being executed. And fourth is waiting. The process is waiting for some event to occur. And finally state is terminated. The process has finished execution. But note that, only one process can be running, but many processes can be ready and waiting.
Now we define a lightweight process. A lightweight process, LWP, is a means of achieving multitasking. Multiple user-level threads, managed by a thread library, can be placed on top of one or many LWPs, allowing multitasking to be done at the user level, which can have some performance. Finally we go to threads. A thread is a basic unit of CPU utilization, consisting of a program counter, a stack, and a set of registers, and a thread ID. A thread is considered lightweight process. We have single and multi-threaded processes as shown in the figure below. The following table summarizes the above. And it is a comparison of programs, lightweight process, and threads. Program, a collection of instructions that perform a specific task when executed by computer. Process means a program is in execution. Lightweight process is a means of achieving multitasking. Threads, whereas thread means a segment of a process. And also, program has a longer lifetime. A process is mostly isolated. Lightweight process, it is a kernel-supported user thread. Threads, whereas threads share memory. Program hard disk stores the programs, and these programs don't require resources. The process takes more time to terminate. Lightweight, it belongs to user process. Threads, the thread takes less time to terminate. Program, it is a passive entity such as a file stored on a disk. Process, it takes more time for creation. Lightweight, it takes more time for creation. Threads, it takes less time for creation. Let's go to search about second point for today. Second point is, how is the program divided into more than one process? Let's find out how to share the data. Cooperating processes require some type of inter-process communication, which is most commonly one of two types: shared memory systems or message passing systems. Figure illustrates the difference between the two systems. Shared memory is faster once it is set up. Shared memory systems. In general, the memory to be shared in a shared memory system is initially within the address space of a particular process, which needs to make system calls in order to make that memory publicly available to one or more other processes. Message passing systems. Message passing systems must support at a minimum system calls for send message and receive message.
Now, we will take about the last point that took about definition and usage of kernel thread and user thread.
Users OS does not recognize user-level threads. Context switch requires no hardware. Support context switch time is less if one user-level thread performs blocking operation, then entire process will be blocked. User-level threads are designed as dependent threads. Example, Java thread, POSIX threads, kernel-level thread. Kernel threads are implemented by OS. Kernel threads are recognized by OS. Implementation of kernel thread is complicated. Context switch time is more. Hardware support is needed. If one kernel thread performs blocking operation, then another thread can continue execution. Kernel-level threads are designed as independent threads. Example, Windows Solaris. And the following figure explain what we took about. Now we finish our point for today. Thanks for watching.
Good luck.